So this is a very topical panel, I suppose. The subject was basically AI is ready for the world. Is the world ready for AI? But more importantly, more specifically, are enterprises ready for AI? And that's what we want to talk today. We got a really nice mix of panelists over here with different backgrounds and from different companies. So let's take a moment to introduce ourselves. We'll start with Manuel.
Hi, everyone. Manuel Salgado, a Senior Manager of Data and Analytics for McKesson.
Chris.
Hi, I'm Chris Simicott. I'm the Chief Data Scientist for City Architecture and Technology Engineering.
Hi, I'm Taylor Smith. I'm a data scientist at State Farm.
This is Praveen Mohan. I'm one of the data scientists for Verizon. We're moving from BI to AI, and we're making the journey so it's appropriate.
Hi, I'm Erin Liddell. I'm a machine learning scientist at H2O AI.
Thank you, and Vinod Iyengar. I do product marketing at H2O, and my background is data science. So let's start off with, so the three aspects to it which I wanted to cover. The first is on the technology side. What do enterprises need to do on the technology side? And Praveen, you mentioned that you guys are trying to move from BI to AI. What are the technological implications, hurdles, and challenges that you're facing?
Technology-wise, I'll like to split that into like 2 or 3 parts to it. Technology-wise, we started the journey with enabling the apps on mobile. That's number one, and then we wanted to also make it cloud ready. So most of the applications, so the technology has to be ready. For instance, some of the vendor-specific products cannot run on certain platforms. So we're working through that technology challenges. Without mentioning names here, they have their own cloud instance and applications can run there. So that's one of the aspects, making the applications actually able to run on different platforms. Secondly, the transformation is small data to big data. So that's everywhere, I guess. It's common. You cannot ignore the fact that now we have access to more data, and we are seeing value in harnessing the big data and the intelligence you can get out of it. So that's the second aspect. And the third aspect is the BI to AI migration. So a lot of companies have already seen the value behind doing business intelligence. There's absolutely no company, I think, on earth right now who's not doing BI. But even though you're enabling the applications and putting them on cloud and mobile enabling them, it's still, the applications are pretty dumb. They cannot think for themselves. That's where the AI piece comes in. How do you enable the applications to think for themselves, do predictive, prescriptive modeling, and that's where the data science will help.
Great. So Chris, you're probably thinking that we've been doing this for a while. Like, as a data scientist, all the intelligence is already there, but companies are really far behind in terms of like putting it into production or like making it available to their end users. What are the challenges you're facing, and what are the solutions for those that you guys are exploring?
So I think there's a couple of types of challenges that occur. One, at least from our standpoint as an industry, is regulatory. I mean, it's one thing to use some sort of like regression-based model. It's something else to use like deep learning. You probably don't want an adverse credit decision being made based on something that you couldn't define, like, oh, I declined you because this black box said no. that doesn't seem satisfactory, and the customers deserve better than that. I think some of the other is just a matter of like having the right skill sets across the enterprise. Certainly, while we have a lot of quantitative people with a lot of good technical skills, like from different partitions of sort of like the data science Venn diagram, doing that with like the modern tools that are available instead of some of the legacy applications, that's still a challenge, getting people trained and up to speed on that, and then also adding the complexities of some of the big data frameworks, like whether it's Hadoop or Spark or some other like H2O's in memory platform.
You brought up a good point about the regulatory concerns and how to overcome that. Manuel, you probably have seen a lot of those concerns, especially being in the healthcare sector, which is highly regulated. What are the challenges you guys are facing, and how are you overcoming it?
So I would say that there's challenges in three main fronts, right? And those are people, process, and technology. On the people side, in order, I think that the topic is how to get ready for AI or how to take it to the next level, right? So it requires a fundamental shift in mindset, right? When you're looking to leverage AI for a particular use, it's different from the traditional paradigm of how we build products, right? You have to think about, it kind of like flip it on its head and say, no, I have the data, I just want to figure out what my question is, and then I'm going to let the data answer that for me and help me to use that answer for future outcomes that I'm trying to drive to. So that fundamental shift in mindset needs to be there. From a technology perspective, at the same time, we have one of the things that has been challenging over the last few years is the amount of investment that you need to make for in platforms so that you can get all of your data in one place, and that the processes that you need to have so that you can make it usable. And in that space, there's been quite a few advances that in particularly cloud computing and the capability that we now have to leverage that technology to be able to quickly stand up a platform on which to do this work. So I think that those two things, and of course then once you have this great, you have the great idea, now you have the technology to do it, then comes, how do you implement that into operations, right? How do I take this concept, how do I make it into, so that my frontline people can actually use the signal from this model to actually make a better decision. So I think that those are the three things that we're looking at.
So, Aaron, from a machine learning perspective, or data science, we are a machine learning software company. What can we do? What are the things that we could do to help companies sort of bridge the gap?
Well, I think we're actually doing a lot of these things already, but maybe I'll just talk about some of the things that we're doing. So I think we made a big step forward when we introduced the GUI for our product. So I don't know if you all know this, but sort of originally the Flow GUI was sort of a demo tool, and people saw it and thought that this was very, easy to use, and it expanded our users beyond people who could write code. So I think that's important, because not everybody needs to do all the things that a well-trained data scientist can do. So that's one thing. I think making the cluster, so a couple things about doing machine learning on big clusters. So one, setting up the clusters, making that very easy to do, which you can also do through a GUI. And then on the other end of things, deploying the clusters. So I think that's kind of what Steam was all about. And a lot of you probably haven't used Steam yet because it just came out, but that was sort of our vision for that, is sort of one-click deployment. So I think just making the tools easier.
So you bring in the point of democratization of data science, so that also brings a parallel question. There is a clear dearth of data scientists. There are just not enough data scientists around to go. So, Taylor, in your perspective, how can companies quickly train a lot more data scientists? How can they get them up to speed? What can they do? Or is it training the developers, or you have to get a
So we're kind of in a unique situation here, and one that I think a lot of the banking professionals here will kind of identify with. We've been doing traditional statistics for decades at this point. We're inundated with actuaries, and that's brought its own challenge. But we have these professionals who understand the guts of the algorithms, and these statistical precepts, which are greatly, extremely important to how we change our processes and are saving money, delivering solutions to customers. So in terms of training data scientists, you almost get this situation where you have the citizen data scientist, right? So training up actuaries, training up, like you mentioned, traditional BI analysts to, adopt these new machine learning models. And again, we're kind of in a strange situation, kind of like you mentioned, where GLMs sometimes reign supreme. You got to be able to explain why you denied someone a policy versus someone else. But I think we're in a really strong position just based on the people we already hire and what we're already working on and have been for a long time. So a little different for us, but I'd say it's almost more of a tooling challenge for us than anything else.
Is this a sort of like a fundamental challenge? I mean, I'm almost wondering, or do you see anything promising? Like, so how do you get to use something like deep learning for solving credit decisions? Like, or like, because I don't know if you have it.
I think one piece is because there's one of the things, like when you do like, you have like autoencoders, you have these things that, once you go deeper into the network, it's finding interactions that, if it's in a GLM, you can expressly define it. Well, some of our regulatory constraints mean not only can you not expressly use certain data characteristics about an individual, you can't use ones that would infer those things. So there's a lot of latent, factors that can occur, and that's one of the problems with, a deep learning approach is that, well, how do I know that I didn't run into that?
Right. And so does that mean we need to like sort of help change the regulations, or do we try to like be cautious about the models, or like how do we look at the interaction effects, or maybe?
I think it goes more into deeper diagnostics of the models, because the regulations are the regulations, and by and large, it's more to protect the consumer. So the onus is on us to make sure that, we're making sure that people aren't discriminated against unfairly, that the decisions are made for sound reasons. So, we need to be able to pick apart the, any like derived features, what compose these things, what does it actually represent, to make sure that, it's not something that's prohibited.
And do you see something on the open source side or something on the H2O roadmap that helps do some of these things, like help interpret more like these difficult models?
Well, there's a couple of things. One, I think just tools that let you inspect the models a little bit easier. And I guess when I say inspect the models, if you have a black box model, that's not going to help that much. But there's a new algorithm called Lime, and that is what people, I think, are using now, or at least trying to use, to get sort of an explanation for an arbitrary model producing a result and figuring out what led to that result. So I think it stands for like locally interpretable model explanations, I think, Lime. So, so that's something we're looking at on our roadmap. So just tools that can kind of explain predictions for a black box model, and there's a couple different approaches to that.
I mean, there's also plenty of use cases like very large enterprises. Not everything's about like lending or credit or things like that. I mean, there's a lot of use cases that we do for like smart data centers and things like that, where we don't have those constrictions. Like nobody cares if you use a black box model to figure out when somebody's hard drive is going to crash.
Right. So that also sort of leads me to my next question is, how do you what kind of architectures are you guys building to have this seamless deployment mechanism? So you have some black box models, some like GLM, like simple models, and some like, but have them all be running in parallel for different use cases. So what's the stack for that? What are you guys architected for that? Manuel, do you want to go first?
Yeah, so for us, we look at the combination of models, right, or actually an ensemble of what different models would give you, and measuring that against the actual results. It's that feedback loop where you take those predictions and then you verify them against what actually happened, and then take that for the model to learn. I think it's very key, and having different models that can kind of tell you, one model might key on something, the other one might key on something else, and actually the combination of models might give you that answer, the best answer, which it takes the for example, the 3 different models, the deep learning, GLM, and GBM, and would give you the actual line that's kind of like the consensus for all of those, and that might actually be the best decision in a lot of cases.
Praveen, what's your...
No, yeah, I just wanted to touch on the architecture that we're doing for enabling our finance partners. I represent IT, but we work closely with the finance. But so I talked about big data. So that is a very key aspect. We have to cater to that in terms of technology and the platform we're enabling. So we're partnering with Hortonworks and deploying their stack of Hadoop and all the Spark and other tools that come with the HDP stack. So that's a key aspect. We have a pretty large on-prem cluster. So the framework that we are looking to roll out is first, the modeling, the prototyping aspect of it, I don't think that it's going to change too much. But the deployment aspect of it, the CI/CD, how do you roll out once either from your desktop or from your sandbox cluster, how do you roll it out to production? How do you enable that application for a point of sale application? How do you show the score of a customer on the screen when the point of sale is happening? So those are the applications. So your architecture should support these products and deployments, basically.
And if I may, actually, that's a very good point. On the infrastructure side, one of the things that we're looking at is I think I mentioned this before, cloud, right? And how that could enable you to have a faster time to market if you can very easily, provision the capacity you need, when you need it, as opposed to having to have this huge investment up front for a on-prem bare metal type environment. So I think that one of the things that I would advise anyone looking to get into big data, advanced analytics, is to seriously consider the cloud offerings out there, because they're getting to the point where they make sense in a lot of cases. In particular, if you're starting out and you don't know exactly where you want to take it, it allows you to start small and then keep growing as your needs change. So
architecturally for us, the focus has been on the enterprise data lake model, creating a centralized, de-siloing everything from all the traditional warehouses and putting it in one place. I mean, we have mechanisms in place to preserve, like, where access shouldn't occur between certain things, but by and large, all the data is sitting in one spot now in a giant Hadoop cluster. And it's been a movement from just the support of batch workloads, which is sort of like the MapReduce golden child, and then moving into more ad hoc support and mixed workloads, and then moving closer and closer to real time, or at least sub-second responsiveness, whether it's through API calls or just the tools are built to purpose that way for like real-time ingestion or real-time processing.
What's happening at State Farm? How are you guys doing it?
Yeah, so we're kind of in the same boat here. We're in the process of kind of dissolving these legacy data warehouses we have and migrating things all into Hadoop. So we're operating on the Cloudera stack. Nearly everything we're doing right now is geared around what we're calling our enterprise Hadoop system, right? And the idea is that all of this data that State Farm has, and we actually have more on hand in the Library of Congress, and we need to move that all into Hadoop. It's massive, right? And that's the pattern we're seeing all over the place.
Cool. As I'm going through questions, I want to make this an interactive panel. So I know we have a couple of those microphones. So if anyone has questions, please feel free to interject. If you have a specific topic that you would like to focus on, there's a good chance to do it. But I'll continue to ask. We'll continue to do our discussions over here. Cool. So, all this hype around AI, right? I mean, so with deep learning, and we had this really nice workshop today. A lot of people are interested in ImageNet and stuff. Are you guys doing anything cool with deep learning in any use cases which you would like to share?
I'll jump in here. State Farm is really investing in the research side of computer vision. We've done a lot with. Actually, we're the first FAA-certified insurance company, and maybe, any large enterprise to my knowledge. But we're engaging in a project called Sky Scout right now, where we're using UAV imaging to predict damage on homes. So, after Hurricane Matthew, we actually deployed an emergency response team out in Florida to fly UAVs over a lot of the affected homes and kind of determine the damage level. So we've been heavily investing in convolutional neural nets in that sense.
That sounds really cool. Just there's a question on that side. Yeah, go for it.
Important. How important is interpretability to the models that you build?
I think that's really use case specific. Again, like if it's something with consumer lending or a banking function, there's most likely regulatory requirements that say you have to be able to explain it. some of the IT functions or some internal functions or compliance things, those needs, or cybersecurity, for example, it can more be about, as long as you can generally point out what was influencing what happened, you probably don't need to be able to decompose it the same way you could with like a linear regression or even just a general GLM.
That's another question there.
Yeah, I have a quick question. So in some of the companies I've been in the past, we created a data lake so that we would have an analytics base where we could create a lot of analysis, right? But it was not really real time, and it didn't really impact the decisions that were going on. Can you talk a little bit about, you guys have kind of talked a little bit about moving to the real time. Can you tell us a little bit about how that's gone and how you're progressing at your companies?
I can talk briefly here. For example, on the finance space, it's internal finance space, it's very important that the data is very timely, and we always have requests that it needs to be faster. The reporting needs to be faster. I need to know what happened today, as of this minute. So that's one of the aspects that we're looking into is the real-time data ingestion, and there are vendors who provide that capability, even in the big data space. For example, if your large amount of data is sitting on one of your many ERPs, there are engines that can ingest the data almost real time. It's still not going to be real time, but relatively speaking, it's real time for if you're talking about Hadoop. So it's still batches, but it's micro batches, if you will.
More or less the same in some senses. We have enough like real-time piping for some of what's going on. We have like a trader surveillance use case where basically, we're looking for market manipulations as the trades are occurring. And then also, again, going back to like cybersecurity, you want to know as soon as possible when there is a likely threat of infection. So a lot of behavioral detection as like the net flows are going.
There's a question on that side.
Oh, hi. Thanks for the insightful info thus far. I had a question on regulatory. I heard a couple of folks already talk about that, right? So we are, as financials, we are just inundated with a lot of regulatory work, and it's a huge time-sinking, consuming activity. So I just wanted to know if you're aware of organizations where AI is actively being used to fulfill regulatory obligations in a more efficient manner, and if there are a bunch of those solutions available that can easily be applied.
I mean, there are some solutions for like anti-money laundering. That's an area where you just have to be able to report suspected activity. Usually the government doesn't tell you whether they did something or not once you file the report, unless it made the headlines in the news.
Yeah, I think anti-money laundering is one use case that we've been seeing quite a bit as well. Regulatory side. Okay. Those are useful questions. So coming back to the question of personal, I had to want to cover one other thing is, we've seen with the customers that often the data engineers, data scientists, DevOps, IT organizations, they all seem to be siloed, and the interactions are quite different, and it's part of it is technological, part of it is where they sit, and part of it is just that they don't speak the same language. So your data scientists are working in R and Python, and you have production systems running in different stacks. So how are you guys helping bridge the gap? And, are there easy solutions for others to follow?
That's what keeps my team employed. I mean, I think it's something that it's going to be a consciousness for the whole organization to sort of get more level in terms of the vocabulary being used and how things get talked about. But at least in this sort of more transition phase, my team interfaces directly with the businesses, as well as, since we're from the engineering architecture function, we deal with like our parallel functions for like Hadoop engineering or for like ETL or something else to make sure that those vague business requirements become something at least an engineer understands.
wanted to add one of the ways we tackle that is to make sure that physically break down the silos. So in an agile mode, if you have a team, you have the functions sitting right next to each other, whether it's the business, you have DevOps, you have data scientists, data engineers. So one of the things that needs to happen is for physically for those barriers to be broken, for people to be co-located as much as possible, and then to make sure that we use tools like H2O, for example, to bridge some of that gap, right? Because the fact that you can do something without having to code anything in data science language like Python or R, right? And then you can use that to show some business user, hey, this is what the model is telling me that is a critical factor for this particular decision. Does that match the insight that you have from the field, right? And if not, then you can very quickly get that loop and address and tune and optimize, right? So I think that key is that co-location, that breaking down the physical barriers.
I would like to add one more thing to that. That's a good point, actually. And creating forums where meetups like this could help. Online crowd around, whatever tools you guys use in your company, we use crowd around. But that's something that will bring people from different disciplines, IT, finance, other groups, marketing, to come together, learn, and share the learnings, basically. And we have conferences. We bring the scientists together just to speak the same language. That's very important. And and secondly, we're trying to change the mindset. We are in the mindset, oh, this is an IT job versus this is somebody else's job. No, even to create a ticket or request, or only this person can create or this group can create. No, now we enable everybody to create, everybody to participate, everybody to update that ticket, and just be more open, I guess.
I was just gonna definitely, because breaking down the physical barriers in a lot of senses is desirable, but for certain globally distributed teams, it's not super feasible when you have to support 160 countries or something, So that it's sort of a mix. Do it where you can, for sure, in a physical sense, but also the online collaborations, having forums internally. We certainly have a lot of that going on to just kind of keep the conversation going, to present what's going on, not just from the technology engineering perspective, but also actual successful use cases and things that have moved from a POC phase all the way to production use. And then, I lost the other point, I'm sorry.
Taylor, did you have something to add? I saw you raise your hand.
I think one of the things, if we're all honest, this is something that all of our teams struggle with. And I think this is probably the biggest thread that you could pick at for any one enterprise. It's moving that product from ideation into something that's running continually, right? And one of the solutions we've approached, and I can't say that it's necessarily the right one, but we've begun to standardize what languages we'll use for a project that's deemed discovery versus one that is deemed initially that this is going to go into production. So we're a Python shop, and as I said, we're moving everything into Hadoop, and so that means a lot of our data engineering team is kind of a PySpark advocate. And so we try to do a lot of our ETL there. A lot of our modeling happens in the Python world, and H2O as well. And then, when it comes to production time, we've got a data engineering team that's, they're users of Python as well. So it's easier for them to pick up a model that we've built there and move it into an ecosystem that they can understand and support. So I guess for us, it's just getting everyone on the same page using the same technology.
The other thing I remembered, it was about the self-service sort of and user empowerment enablement. We have groups that still have specialized functions, because some of that's just making sure that there's a trail that can be followed, that something happened. Now that we're working with certain vendors and we remediate a lot of those lineage gaps in their products, we can start opening it up more so that the users can be more self-sufficient.
That makes sense. Just related to that, this other question is, and I've seen this in some organizations where you have what you call like a data science center of excellence or like a machine learning, and often that group sits in a labs environment or in a separate office. And I don't know if there may be pros and cons to it as compared to having your data scientist, data engineer, IT person combo working in pods in the actual business unit. And is there one or the other that you guys prefer, or what have you seen success with?
So my team, we have a data science center of excellence under my team. So we actually, we are a centralized function, and then we support the businesses. But we also have a mechanism where we would hire somebody and train them as if they were for our team exclusively, and then eventually we'd release them to the business if it's part of a longer term initiative. So I think it is not this or the other. I think I think you've seen that in the tech sector, you know, startups where they went one way or the other, and that would create its own set of problems. I think it has to be both to some extent. You know, it needs to kind of like organically grow inside the business, but if it's getting seeded by some central piece, as long as, you know, there is like both happening, it doesn't really matter how you got it there.
I would just add, there are certain functionalities that we see it's shared among other groups. For instance, the Center of Excellence that you mentioned, we do have one data analytics group or organization, but at the same time, we have people belonging to marketing and finance and other areas working within the business itself. So the functionality that usually the data organization team focuses on is coming up with common tools as a recommendation for specific needs. So that's one thing I wanted to share. So
yeah, I think we have I personally have seen both centralized and decentralized on the extremes, and I can agree that you have to have a hybrid model, right? It's good to have a center of excellence that's centrally located, that can look at the general types of problems and look at the big picture, architecture tools, whatnot. But understanding that at the business unit level is where the actual, where the rubber meets the road, and where you're going to have some knowledge that just by necessity is going to be there. So having an approach where you have that connection. And that in real time, being able to leverage resources when you need to, but also have dedicated resources at that level as well.
Yeah, so I agree. We're in a center of excellence at State Farm, and you get the pros of having people who have a broad array of talents, right? So I work in text analytics. I've gotten to apply that to claims. I've gotten to apply that to legal, different projects across the, within the business. And so you get the advent of having these people who have a broader array of skills, I think, within data science. One of the conflicts of interest I've seen, and we've begun to change our model a bit, is a lot of times if you interact within a center of excellence with a business partner, they may not have any incentive to move your work into production on their dime. And so you have to come up with this kind of coalescence of their interest meets your mutual interest. And so something we've been exploring early on is the onus is on the business partner to prove out that there's money in this before we allocate our resources there. So I think that's a challenge that a lot of people, or a lot of companies, right, kind of come into when they adopt that center of excellence model.
We're slightly more permissive in that if we believe in what's going on, even if it's not like, oh, I can definitely prove that this is going to happen, we allow for a degree of co-investment. So then we'll absorb some of the costs for the resourcing, not just ask the business to supply the whole thing.
And what's your take on this approach towards optimization? What would you recommend as an expert from the H2O side?
I guess I've worked in very large organizations and then startups, so maybe it's the extremes. So I don't have as much experience hands-on, but I would have to say probably a hybrid approach is good. I think it's good to have a place where people can come to for training and for mentoring and that type of thing. Yeah, it gets tricky when resources have to be accounted for and that type of thing. So I think it's good to have a center.
One last question I want to end before we end the panel is, So the maker culture, we care about a lot, and part of the reason why we are fully 100% committed to open source is because we want to build code and build software that stays. And I know big corporations are now beginning to do that too. I mean, every company now, they want to call themselves a software company which does X. So State Farm being a software company that does insurance and so on. Are you seeing a big movement towards like actually putting out stuff on open source, like actually creating valuable product or code and it's also a recruiting tool, right? I mean, if if you want to get the best people to work on your team, you need to give them some incentive. Are you seeing those kind of initiatives come up?
Yes, so we're a huge enterprise, and for the most part, we've been a very closed source company. So we operated entirely on IBM stack. We still have a DB2 warehouse out there. All our actuaries are using SaaS, but we've begun in the last few years to migrate towards this open source model. And our team has seen actually invested such an interest in it that we're talking about implementing this 20% rule, which is something that Google kind of coined a few years ago, where we're going to allocate 1 day a week for all of our researchers and scientists to be able to contribute to either their own projects or ongoing open source projects, or just delve into the literature. So we've, I think, put so much into this idea of open source that now we're taking time to really focus on it at work.
Our big data group has actually created a lot of inroads in terms of how we view open source more generally for the enterprise. And so while the adoption of open source has become much easier than it was before our group came in, our ability to sort of give back, that's still, we have policies that kind of restrict that sort of activity. So I think while there may be some contributors who are certainly willing, that there are things that would hold us back from being able to fully commit. Although we do work with certain vendor partners to kind of like, if they can, re-implement something that we've done, they can commit it back, something like that.
And your personal take is to move towards that, or?
I think we need to increase our flexibility. I think we will. It's just, we started from you can't have any open source at all. So I think we've made a lot of progress. So, but it's, like everything else, it's going to be sort of like iterative, right?
Cool. There's one. Is that a question? Yeah. Right over there. Yeah.
How do you maintain the maintenance of the model for your futuristic agile work? Like, how do you maintain it? Is that some process you follow, or how do you maintain this model?
If I may paraphrase, are you saying about model degradation, or yes, how do you constantly keep updating models? Okay.
I'll dive in. We have a very formal model review process. This is common, I think, with a lot of industries that have heavy federal regulation. We have a model reviewer who will spend several months going through and documenting your exact model, trying to beat it, trying to replicate it, and determining whether he thinks it's overfit or not. And he comes up with, I can't speak to how, but he comes up with a timeline. He says, this model passes, we'll refresh in 2 years, something to that effect. And I suspect it's similar, but we, from the onset, then define what our refresh cycle looks like.
So how do you manage it?
So again, if it's something with a regulatory requirement, there's usually a decision management group that plays the role inside the business to control that sort of activity. If it's something more where it's new, like maybe for its technology capability, and we just want to figure out like, well, how do we know that this behavioral detection model for like malware is still valid, or if we're accurately predicting changes in hardware when the next generation of hardware comes out. That's more about a mixture of some manual monitoring to see if performance looks right based on some what's been happening in recent history. Also, if we can try to embed some automation to that, so that if we see degradation, we can do model refreshes.
With that, I think we have unfortunately come to the end of time. We are overboard. I know this panel says still 5 minutes, but thanks a lot, all of you, for joining us and for this really productive discussion. I think hopefully it was very insightful for folks who got a few strategies for themselves to use for. Thank you. Warm round of applause for the panel over here.